All right. Who can tell me what is data? You at this point you can even Google the answer, copy paste the answer in the chat, or you can unmute and tell me what the answer is. It's not that difficult a question. Data can be described in one word, even. My apologies. Yeah. What can data be described as? What's another word for data, rather? Let's say that. Anybody got an idea? Facts, we could say facts, yes. Or rather the word I was looking for, and I'll tell you now. Facts and statistics. Yes, data handling is known as statistics, really. But what we're actually looking for when we talk about data is we're basically talking about information. It's information. That's what data is. But in this case, it's going to be raw, unprocessed information. Okay, so it's just information that you've been given. You asked a question, people gave you information on that question, and now you need to do something with that information that you've been given. All right. So when we talk about data, we're just talking about what information has been given to us. What are we going to do with it? That's the processing part of it. All right. Then we definitely get different types of information. We're either going to get qualitative or we're going to get quantitative. Now, if we look at both of these words, you can see that they both have root words. So if we look at the word qualitative, we know that that first half of qualitative actually has a root word. The root word here would be quality, right? Quality. And if we look at quantitative, we know that this first part over here that says quanti, that is also our root word. It would come from the word quantity. And both of these things speak exactly to that. All right, I'm going to speak about quantitative data before I speak about qualitative, just because it makes it a little bit easier for us to get. All right, so quantity, we know quantity, or the word quantity almost says something like how much. Okay, how much? The quantity is basically how much of something there is, right? So when we when we collect quantitative data, we are looking for data that is given strictly in numbers. Okay. Like, let's say, for instance, we want to know how many cars were parked at the mall on a particular Saturday. That is going to be quantitative data because we're going to count how many cars come to the mall. And then we'd say, on this particular day at the mall, there were 7,432 cars, which is quite possible, actually. All right. And that's how we get numbers. Or if somebody asks, let's say, for instance, we are going to measure the height of everybody in the grade 11 or in grade 11. Height is also going to give us numbers. Everybody's height is going to be different, but it's going to give us numbers nonetheless. So one person would be 1.64 meters tall, 1.64 meters. Somebody else would be 1.8 meters tall. Somebody else would be 1.52 meters tall, so on and so forth. All of the answers that we'll get will be in the form of numbers. And that is quantitative data. Now, qualitative data is when we ask for a specific word, just like quality. Quality is what is, like it's a what, right? We're talking about what something is. Is it good? Is it bad? Is it soft? That kind of thing. It's quality. We're checking for the quality of something. So when we look at that, we'd be talking about things that people would have to give us words as answers for qualitative data. Like, let's say, for instance, if I had to ask both of you, can quickly pop your answer in the chat. What is your favorite flavor of ice cream? What is your favorite flavor of ice cream? You can pop that in the chat quickly. Vanilla, okay. A little boring, but it's okay. We'll take vanilla, sure. Nomso, I like caramel. I do. Okay, cool. So do you see how both of you as answers, you've given me words as answers. One of you has said vanilla and somebody else has said caramel. Right. So Qualitative data in this case is when we are given words. We're given words as answers to our particular question, and we can see the difference between the two. Now, we can take qualitative data and turn it into quantitative data by asking how many. We can take the qualitative data and ask how many, and then that changes it into quantitative data. Now, let's say we are polling the whole of the grade 11 set, and we're asking them, what is your favorite flavor of ice cream? And then we record that 18 people said that they like caramel, vanilla, and then we find 27 people liked caramel, 14 people liked chocolate. Do you see now how we are taking the qualitative data and we're turning it into quantitative data? We're turning it into numbers. Can I get a thumbs up with your reactions? Are we all good with what ma'am has done here? We all good? Lovely. Okay, so that's the difference between qualitative and quantitative data. Now, we can split this up a little bit more, and this should not be here. This should be over here, because this is actually what we're going to talk about. All right, we can split quantitative data into two more categories. We can either have discrete or we can have continuous data. Now, for this, I'm just going to start with discrete data. Discrete data is when we talk about whole numbers, things that are whole or set numbers. Okay, so let's say, for instance, if you are asking people, if you're going around school and you're asking everybody, how many siblings do you have? How many brothers and sisters do you have? There's nobody who can come to you and say, I have 2.7 brothers and sisters. Because what is 0.7 of a brother or 0.7 of a sister? It doesn't make sense. Okay, so discrete data needs to be whole numbers. So if you ask somebody, how many brothers and sisters do you have? They will say, I have one brother, or I have 2 brothers and 1 sister. They will always give you a whole number. It won't be anything like a decimal. All right, so that's discrete data. Continuous data is exactly the opposite of that. It's data that gives us information that is not fixed. Okay, that is not fixed for every set. Like, let's say, for instance, if we asked everybody for their height, we get too many different answers. So somebody will be 1.54 or 6, 6 is too tall, 2.01, 1.88, things like that. Those are continuous data. None of it is fixed. It will change all the time depending on each person and the situation that we are measuring it in, how many decimals we're measuring it towards. That's also something that we have to take into consideration. All right, thumbs up. Are we okay with the difference between discrete data and continuous data? We good? Yes, lovely. Okay, cool. All right, let's look at a quick example on how to answer the questions that we've been given here. So what we've been given here is a table, and we call this table a frequency table. It's very important that we know that. Okay, and the reason why I say we should know that is because sometimes in MathLit, they don't tell you, or they don't give you a frequency table. They might just say to you, draw a frequency table. Now, you need to know exactly what a frequency table would look like. Okay, so let's talk about what it means when we're looking at a frequency table. Do we know what frequency means? Anybody know what frequency means? No, Tiama's like, nah, ma'am, I don't know. No? Nomso, any idea? Okay. All right. So frequency means how often we do something, right? Like the frequency of you going to school, you go to school 5 days a week. That is something that you do frequently, right? The frequency of a show on TV, it either plays once a day or it plays once a week, depending on what it is. That is the frequency. How often somebody buys a newspaper, right? Or how often newspapers are released. They're either released weekly or they are released daily. Same with magazines. You find that either a magazine will be released weekly or it will be released monthly. That is frequency. So the frequency means how often did something happen? How often does an event take place? Okay, so let's see what they've given us over here. So they say, the following grouped frequency table gives the points scored for a girls and boys basketball team. So we're using the same um, frequency for both the girls team and the boys team. Excuse me. All right. So what we see over here is how many times did they score between 0 and 9 goals? They didn't. Nobody did. Right. How many times did they score between 10 and 19? None of them did. But when we get to 20 and 29, between 20 and 29, the girls' team scored 5 times and the boys' team scored twice. So what this tells me is that the boys' team scored between 20 and 29 twice. That means they may have scored, I'm just going to make this up, maybe 24 and 26. Let's just say for 2 of the games that they played, they scored those 2 values. Now, for the girls, they played 5 games where they scored 20 or 22, and the other one could have been 25 or 23, and then 28, and then 29. So 5 of the times when they played a game, they scored values between 20 and 29. Thumbs up. Am I making sense here? Are we all good? Lovely. Okay, good stuff. So we don't know exactly what those numbers are, but we know that 5 of the times the girls scored between 20 and 29, and 2 of the times the boys scored between 20 and 29. Same with 30 and 30 to 39. That means 6 times the girls scored maybe 31, and then 34, and then 30, and then 36, and then 39, and then 30 again. Okay, so when we add all 6 of those up, or when we look at all 6 of them, 6 of them fall in between 30 and 39. All right, okay, let's look at the information or the questions that they've asked us in terms of this question here. All right, it says, use the group frequency table of basketball points to answer the following questions. It says, how many times did a team score above 70 points in a match? Was this a girls or a boys team? So I'm going to pose the question to you guys. How many times did a team score above 70? If you look at the table, just let me know if the table isn't big enough. I can expand it just so you guys can see a little bit better. Okay. If we're not sure of the answer, you can also say, ma'am, I don't know. I'm more than happy to help. Once. Okay, Nomso says once. Okay. All right, let's go look at it again, because it's not once, it's actually twice. Okay, let's look at this. They say they're looking for a team that scored above 70 points. Now, if we go to 70, there is 70. So this would be 70 and above, and this would then be 80 and above. So above 70 would be that game and that game. All right. So how many times did a team score above 70? It's 2 times, right? Was it a girls or a boys team? It was the girls team. Okay, thumbs up. Is my answer making sense? Okay, lovely. Okay, cool. Good. That's perfect. All right. Okay, let's look at the next one. It says, what was the most frequent number of points scored by a girls' team? Give your answer as an interval, because we won't know the exact number. We're just looking for the number with the highest frequency. Okay, so which number, or what was the interval with the highest frequency? So they're asking us which interval has the most. So is it from 30 to 39, or is it from 60 to 69, or is it from 70 to 79? Which one of those points scored intervals happened the most for the girls' team? Which interval would that be? Which one are we looking for? 40 to 49. That's it. Correct. Lovely. It's 40 to 49. Well done, Siamo. We can see it on the table, right? If we look at the most number of goals scored by the girls, or the points scored by the girls, it's that frequency. And that frequency belongs to 40 and 49. So the interval we're looking for is 40 to 49 points scored. And this is exactly how they want you to answer it. Points scored. Just like that. All right. Okay, let's look at 1.3. It says, what was the most frequent number of points scored by the boys' team? Give your answer as an interval. All right, so let's look at it. What was the most number, or what is the interval for the boys with the most number of points scored? That's it. Well done, Nonso. Lovely. It would be 50 to 59, right? Because if we look at the boys' frequency here, the highest one is 11, and that corresponds with 50 to 59. All right, 50 to 59 points scored. Points scored. All right, let's look at the next one. It says, what was the lowest score interval for both girls and boys teams? Let's go have a look. Now, I don't want you guys to consider any of the zeros. Okay, we cannot consider any of the zeros because that won't tell us anything in terms of lowest. Okay, we need to go look at which part of it have they actually scored goals in. So all the zeros, the parts where there are zeros, those won't count because that doesn't mean that they didn't play a game, right? It doesn't mean that they didn't play a game. It just means that they didn't score that many points. And Siamo, you're spot on when you say 4 for the girls, but we're looking for one. Oh no, yes. What was the lowest score interval for both of them? Okay, so we need to look for the lowest mark where they both have a value. Okay, that's it. Nomso's got it. That's the one. All right. It's going to be 20 to 29. Siamo, are you understanding why we're saying 20 to 29? Okay. If we look at the parts where nobody scored anything, right, we know that this one won't count because the boys didn't score any of those points there. These two up here won't count because nobody scored any points there. So we're looking in this interval to see where the two lowest points are together. And that would have to be 20 to 29 because both of them have really low scores in that particular interval. So it would have to be 20 to 29. We can't use 1 is to 6 because 6 is not the lowest value for boys in this case. Okay. Okay, it's perfectly fine. It's quite a tricky question. But yes, I'm just happy you're trying it. That's the best part. Okay. All right, let's look at the last one. It says, what are the disadvantages of a group frequency table like this? What can we think of? What would the disadvantages be? And I'll give you guys a hint. That first thing that I did at the very beginning, when we had to talk about the intervals, I think that's the biggest disadvantage that we have with frequency tables that have been put up like this. What do you guys think a disadvantage would be? Okay, let's think about it really quickly. If the girls, let's just go to the girls' team. If they've scored 5 games, if they've played 5 games and they've scored between 20 and 29, what are those numbers? What are the numbers between 20 and 29? We're going to have either 20 or 21 or 23 or 24 or 25 or 26 or 27 or 28 or 29. Do we know specifically how much they scored in each of those games? In each of those 5 games? No, we don't. Right. And that puts us at a disadvantage because then our values or our answers in each of these is not as accurate. Am I making sense? Because we don't know the exact value, when it's all been grouped like that, it gives us it's almost like we have to approximate. Do you guys understand? Do you know what approximate means? Yes, thumbs up. Are we familiar with approximate? Or let me say estimate. Do we know what estimate means? It's like a calculated guess, right? We're not able to get the exact number, but we're kind of sort of guessing where it would be. So when we are given intervals like that, like from 20 to 29 and from 30 to 39, we don't have the most specific, most accurate answer. Okay, thumbs up. Am I making sense there? Are we all okay? Good. Yes, absolutely. Okay, so when they say what is the disadvantage of a group frequency table like this, is our answers are not accurate, are not very specific. Okay, which would be better if we did have very specific values. It would make our estimations a little bit more accurate. Okay. All right. Let's have a look at the mean, mode, median, and range. Thumbs up. Have you guys learned about mean, mode, median, and range? Nomsa says yes. Tiamo, have you? Well, I'm going to assume we have, because this is something we learn all the way since from grade 7 onwards. And I know, Tiamo, you're like, no, watch when I start talking about all of them, they're going to come back to you so quickly. All of it is going to come back to you. All right, let's start with the mean. All right, if I have this number of values over here, for the mean, what I'm going to do, and I'm going to represent the mean like that, x with a little line on the top, is going to equal to the sum of, now the symbol that I've drawn here is called the sum of all these values. So we're going to sum up all the values of x, and we're going to divide by the number of values that we have. So that means that, oh, not this year. Okay, that's fine. Okay, that means that our mean, we're going to calculate like this. We're going to go 2 plus 5 plus 6 plus. We're going to add them all together, plus 30, and we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. We're going to divide that by 15. Does this sound familiar? Have we seen this before? Yes. Uh-huh. Mm-hmm. Right. Good. That's our median. All right. Our mode is just the number that shows up the most. Okay. Number that occurs most. Okay. And mode is easy because it even sounds like most. So that shows us that. We can get that. All right, I'm going to skip median for now. And the reason for that is because I want to introduce that with Q1 and Q3. For our range, we know that if we're calculating for our range, we're going to take the biggest number in our data set, and we're going to minus the smallest number, and that will give us the range. Okay. Then for our median is known as the middle number. All right. It's the number right in the middle. Now, our median has another name. Our median is also known as Q2. And I want us to heed that because it's going to come back just now when we're talking about the stuff again. So our median is the number in the middle. But in order for us to get the number in the middle, we have to make sure that our data is organized in ascending order first. All right. So organize data in ascending order. So ascending from biggest or from smallest to biggest. All right. And only then can we look at the middle number. Now, if we look at the values that we've got over here, there are exactly 15 of them. If I wanted to calculate for my median, I would use this formula. I would say n plus 1 divided by 2. Now, this n over here stands for the number of values that we have, right? So if I look at our median over here, I know that we have 15 values. So I'm going to go 15 plus 1 over 2. Can you guys punch that into your calculator for me? Or if you know the answer, 15 plus 1 divided by 2 would give us how much? It's 8. Good, Tiamo. It's 8. Right. So this 8 doesn't mean that this number 8 is our median. No. What this 8 tells us is that we're going to go to the value sitting in the 8th position. Okay, it's sitting in the 8th position. So we're going to start over here. This 2 is sitting in the 1st position. This is the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th position. So the number sitting in the 8th position is 10. That means that my median is actually equal to 10. All right, thumbs up. Does all of that make sense? Yes? Are we okay with mean, with mode, with range, and with median? Lovely. Okay, so next thing we're going to do is we are going to name this median that we've got over here 10. We're going to name it Q2. Okay, and what this thing does, what Q2 does, is it splits my data into my top half and my bottom half of data. Okay, now Q1 and Q3 splits my data again. We're going to split it in half again. So we're going to take this first part over here and we're going to split this first part in half again. Now, if I look at how many numbers we have on the side, we've got 1, 2, 3, 4, 5, 6, 7 numbers. I know that the number in between here is going to be the 4th number. So that one there, that 6 over there, that is my Q1 value. And then if I go to the top part over here and I split 1, 2, 3, 4, 5, 6, 7 of them in half, the 4th number from here, that one will be our Q3 value. And that's how we can split our data in 3. Now, on top of this, they might ask you for the IQR. And the IQR basically just stands for the interquartile range. Interquartile range. And the interquartile range is quite easy to calculate. The interquartile range is just your Q3 number minus your Q1. So if we take this information we've got over here to calculate for the interquartile range here, we're just going to take our Q3 number, which is 24, minus our Q1 number, which is 6. So our interquartile range will then be 18. All right, thumbs up. Are we all good? Everything okay with what I've just explained here? Okay, if there's something that I've gone too fast over and you want me to look at it again, I'm happy to look at it again. We can do that again. Nomso, are we all good? Lovely. Okay, awesome stuff. All right, so I'm going to give you guys a few minutes to calculate this for me. These 3 things, or these 4 things, based on this exact information I've just given here. And I know that I've already done a lot of the work for you, but I want you guys to calculate the mean, the median, the mode, and the range for me, please, using this data here. And just pop a done in the chat for me when you're ready. Okay, just 3 minutes. It won't take us that long at all. All right, that's all the time we're going to afford that. Let's see. Okay, Nomsa just finished, just in time. Okay. All right, lovely. Oh, okay. All right, let's have a look at the answers that we're getting over here. Okay, so for the mean, we know to calculate the mean, we can say x is equal to 2 plus 5 plus 6 plus 6 plus 6 plus 7 plus 8 plus 10 plus 13 plus 15 plus 22 plus 24 plus 26. It's very, very long. Plus 27 plus 30 plus 30, and we divide all of this by 15 because they're 15 numbers, and the answer we should get out here is 13,8. That's the answer I got, at least. I hope you guys got the same answer. All right, 13,8. For the median, again, remember, guys, we said we're looking for the number in the 10th position or in the 8th position, and we know that the answer for the median is just 10. You can just write 10. That's all we need. All right, for the mode, we know that the mode is the number that shows up the most, and we can see from this data over here that 6 shows up the most. So that is our mode. And then for our range, we're just going to take the biggest number, which is 30, minus the smallest number, which is 2, and therefore my answer for the range is 28. Thumbs up. How did we do? Did we do okay? We get everything? Awesome stuff. Lovely, lovely. Okay. All right. Let's figure out what happens when we see something like this on a table, on a frequency table. How do we then use the frequency table to figure out the mean, the mode, the median, the range, and our quartiles for this Q1 and Q3? Okay. So I want to just, explain something a little bit more clearly, because I don't think that frequency tables are explained in much detail. I think many teachers just kind of tell you, do this, and that's how we do it. But we really need to understand what a frequency table is, or what a frequency table does, especially in contrast to getting a set of data like that in a row. Okay, so the reason we use a frequency table is when we have too much data to organize it in a row. And I can explain here. We're looking at a football team keeping a record of the number of goals it scores per match during a season, right? Now, if this is the number of goals they've scored and this is the frequency in which they sold it or they scored, this is what our data would look like if it was all laid out. We would have 8 zeros, and that's why 0 comes first and then with a frequency of 8. So our data, if it was all laid out, it would look like 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then after that, we would have 10 ones. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then after that, we'd have 12 twos. So 2, 2, and on and on and on. You guys get the idea, right? You get the idea. Now, if we had to now take all of this data and spread it out, that's a lot. It's a lot. Imagine doing this and then you find that they've had a frequency of 120. If they've played over 300 games and they've scored 2 goals in 120, nobody's going to sit there and draw out that many twos in a row. Thumbs up. Am I making sense as to why we would condense all of that information on a frequency table? Instead of stretching it all out, we're compacting it so that it's easier for us to understand and people don't have to sift through all of our unprocessed information. Okay, and that's why we do that. All right, so we're going to use this information here to determine the mean, the mode, the median, the range, and the quartiles. Now, let's talk about the mean. We said that the mean would be us taking all of these values. Let's go back here. So we've taken 2 plus 5 plus 6 plus 6 plus 7 plus all of them, added them all together, and we've divided by how many they are. Now, if we look at what's happened over here, I already know that I'm going to get 8 zeros. So I'm going to get 0 plus 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 1 plus 1 plus 1 plus 1. I'm not going to sit there on my calculator and punch in plus 0 plus 0 plus 0, because anything plus 0 is just 0. So I'm not going to do that. And I'm not going to sit on my calculator going plus one, plus one, plus one, plus one. The easier thing for us to do here is to go, how many zeros do I have? I have 8 of them. So 0 times 8, because I have 8 of them, right? 0 times 8. And then I'm going to say, how many ones do we have? There are 1, 2, 3, 4. There are 10 of them. So that's 1 times 10. How many 2s do I have? I have 12 of them. So that is 2 times 12. Thumbs up. Am I making sense? Does it make sense what I'm doing here? Right. Instead of adding one at a time, I can just multiply and add those together. So instead of doing it like that, we're not going to use our table in that order, right? We're not going to use our table in that order. We're just going to go here and we're going to go 0 times 8, and then 1 times 10, and then 2 times 12, 3 times 3, 4 times 5, and 5 times 2. And we're going to total all of those. Now, remember when we calculate for the mean, we have to divide by how many values we have. How do we figure out how many values we have? We're going to take the frequency and add it together, because I had 8 zeros and then 10 ones and then 12 twos and then 3 threes and then 5 fours and then 2 fives. So how many goals or how many games did we play all together? 8 plus 10 plus 12 plus 3 plus 5 plus 2. If I add that in my head, that's 18, 30, 33, 35, 40. This is 40 games, right? So we're going to do 0 times all of that, add all of that together, and whatever answer we get there, we're going to divide that by 40. All right. Thumbs up. Are we okay with what ma'am's just explained here? Okay, lovely. All right, let's do all of that together. So we're going to go 0 times 8 will give us 0. 1 times 10 is 10. 2 times 12 is 24. 3 times 3 is 9. 4 times 5 is 20. And 5 times 2 is 10. Can somebody add these numbers up for me and give us a total quickly before we divide by 20? I mean by 40, sorry. So 10 plus 20, 0 plus 10 plus 24 plus 9 plus 20 plus 10. $73, okay. Yeah, that sounds about right. Let me quickly double check, but I believe you. I 100% believe you. I also get 73. Good. Yes, 73. So we now have 73, and we're going to take that 73 divided by 40. What does that give us? 73 divided by 40. 1.825. Good. So our mean is now 1,825. Now, because this data is discrete, do we remember what discrete means? Yes, discrete means that it needs to be a whole number. It needs to be a whole number. That's it, Tiamo. So in this case, we have to say that the football team scores on average 2 goals per game, because that's what the mean is. The mean is the average. So if you went and watched the team play, you would expect on average for this football team to score 2 goals, because you can't score 0.825 of a goal. There's no such thing as 0.825 of a goal. So we can round that up and we can say, therefore, it's an average of 2 goals. All right. So our mean over here was 73 divided by 40. That is equal to 2, or 1,825. Rather write 1.825 and then say estimated 2 goals. Okay. All right, let's talk about the mode. The mode is just going to be the number of goals that they've scored the most. How many goals do they score the most? We just need to look for the thing with the highest frequency, because if that has the highest frequency, if we laid the information out like this, that's the number that would come up the most, right? So the answer that we're looking for would just have the highest frequency. In this case, our answer would have to be 2, because 12 is the highest frequency. That means if we laid out our information, we would have more 2s than any other number. So our frequency, oh sorry, not our frequency, our mode is 2 goals. Okay, our mode is 2 goals. Now for our median, remember we would have to put our data out in ascending order, right? But it's already been done for us because all the zeros come first, and then the ones come, and then the 2s, and then the 3s, and then the 4s, and then the 5s. All that information is laid out for us. We just need to use the formula for the median. Remember, we said that the median, we would take n plus 1 divided by 2, and that would give us the position. Now, we know that our n is the number of values we have. And in this case, we would have 40 values from our frequency. So we would go 40 plus 1 divided by 2. What is 40 plus 1 divided by 2? Let's see. What are we getting, guys? Okay, Siamo says 21. I'm going to assume you're saying 21 because you got 20,5 as an answer. Are we in agreement? Did you get 20,5? Because that's the same answer I got. I got 20,5. Yes? Okay, so the reason we can't really say now 21 is because we're not looking for an actual number. That 20,5 is actually in place of the position. So we're looking for the number in the 20,5 or 20,5th position. And now that's not really possible when we look at the data that we have. We're not going to have a position at 20,5. So we're going to look for the value between the 20th and the 21st position. That's what we're looking for, the value in between the two of them. Oh, I see. Okay, it should give us 20,5. So we're going to go and count and see which number sits in the 20th position and which one sits in the 21st position. So here's how we're going to figure that out. I know that the first 8 positions are just zeros. Then the next 10 positions are ones. I'm going to ask you guys, if I've counted the first 8 zeros and the first 10 ones, how many positions have I counted here so far? How many positions have I counted after I've counted all the zeros and all the ones? Correct, Siamo, 100%. Good. We've counted 18 positions. But remember, we're looking for position 20 and 21, right? What would fall in between there? If I count the next 12, right, I'm going to be at the 30th position if I count all the way to the end. So if I count this next 12, the 20th and the 21st position must fall in here. Thumbs up. Am I making sense? 20 and 21 would have to fall in that position there where we have 2s. Am I making sense? Siamo says yes. Oh no, we've lost Nom. So I think she's having connection issues. Okay, so we know that the median, or the number that would show up in the middle position, would have to be a 2. All right, Nom, so please just let me know if you're having connection issues. I'm happy to rewind because I can tell that we're losing you every now and then. Okay, so our median is going to be the number 2 at 2 goals. Our range is just going to be the biggest number of goals minus the smallest number. So we're just going to have 5 minus 0, right? So our range 5 minus 0, which just give us 5 goals. That's the range with which we're working with. All right, now to find our median, right? Or sorry, to find Q1 and to find Q3, remember we said that we would split the data in exactly half, right? Our median would split the data in half. So if we've got 40 values, we know that the first 20 values are zeros and ones, right? And then 2 twos, because let me explain that again. This is 8 values. This is 10 values. So together, these two give us 18 values, right? But if there are 40 values altogether, how many values are there in the bottom half and how many values are in the top half? Okay, think about splitting the data in two. If we have 40 values all out in a string, the top half will be how many values? And what would the bottom half would be how many values? And the top half would be how many values? What are we thinking? That's it. Correct, Tiamo. We would have 20 in each half. Right. Now, if we have 20, that's going to be that first 18 plus a 2 and a 2. That makes the top half. Right. Then the rest of the 2s would be down here. Right. With this bottom half of the data. So now we've got 20 values up here. What is the midpoint for those 20 values over there? Right, we've got 20 values, so we can go and find the median of those values that we've got. So we're going to go again. The median of the bottom half. Now, the bottom half is 20 values, so we'll have 20 plus 1 divided by 2. What does that give us? 20 plus 1 divided by 2? 10.5, right, correct, 10,5. So 10,5, again, this is the position, right? It's not the actual value, it's the position. So we're looking at the number between the 10th and the 11th position. That's where we're going to go and look. Now, if my first 8 values are zeros and my next 10 values are ones, then I know that 10 and 11 would fall in between that one there, which means our Q1 would have to be a 1. All right, thumbs up. Am I making sense there? If I'm looking for the 10th and the 11th value, they would be somewhere between the ones. Right, now we're going to do the same with these values over here. All right, so we know that the first 20 have already been accounted for. So the median we're looking for in the bottom half was 10,5, but the median of the top half, we would have to add this 20 first. So we'd have to go 20 plus 10,5, because this part is also made up of 20. These are 20 values over here. So if we add the top 20 plus the middle of those two values, we're going to get 30,5. But again, that is the position that we're looking for. So we're looking for the value in the 30th and the 31st position. I hope I didn't lose you guys there. Are we all okay with what ma'am has just... Do you understand why I've taken 20 and added 10,5? Okay, let me do that again. I'll do that again. All right, so we said that this information has been split in half, right? And if we split it in half, there are 20 values at the top and 20 values at the bottom. Are we okay with that? Yes? Thumbs up? Okay, cool. Now, if we look for the halfway point for the bottom half, that's easy enough because it's just the bottom half. There are 20 values here. We know that to split that in half again, we look for the 10th and the 11th value, right? Now, in the bottom half, there are 20 values, right? There are 20 values. So if I did the median for the top half, I would still have 20 plus 1 divided by 2. Thumbs up. Is that okay? Yes? Okay, cool. Right. So I would still get, for these 20 values, I would get 10,5. But This is not the bottom half, it's the top half. How many values have we already crossed to get to the top half? How many values have we already gone past? We've gone past the first 20. And that is why I'm taking the first 20 and I'm adding it to the median of the top half. Is that making sense? Lovely, good. So if I take that and I add those two together, that's going to give me the 30th and the 31st position. That's what we're looking for, right? We're looking for the values in the 30th and the 31st position. Now, if we count over here, we know that the first 8 values are zeros. The next 10 values are ones. That gives us 18 values, right? If I add 12, that gets me to 30. And then if I add the 3 over here, that gets me to 33, right? But I know I'm looking for the thing in the 30th and the 31st position, the thing in between the two. Now, my 30th value is a 2. My 31st value is a 3. So I'm looking for the value right in between these two. What falls right in between there? It would have to be in between 2 and 3. What value would I get in between 2 and 3? I would get 2, 5. 2, 5. It would have to be 2, 5. Between 2 and 3, 2, 5. Right. But again, because it's discrete data, we would need to say between 2 and 3 goals. Okay, in this case, because it's right between the two values. So between 2 and 3 goals. And that one is a bit more complicated, but they're not going to ask you for a Q1 or a Q3 on a question like this. I just want to make sure. Do we understand how to find the mean, the mean, the mode, the median, and the range? These 4 are very, very important. Thumbs up. Are we all okay with how to get there? Lovely. Okay, Q1 and Q3 will come in, but it comes in a little bit later when we do something a little bit different. Okay, let me see. Okay, so I want us to take this data that you've got here, and I don't know how this thing is actually underneath that thing because that's something completely different. All right, I want us to use this data that we've been given over here to calculate for the mean, the mode, the median, and the range. Okay, I'm going to take out the quartiles for this one because they just complicate our lives and they will hardly ever give them to you here. So I'm going to give you guys about 4 minutes. When you're ready, just type done in the chat for me and then we'll talk about the answers. Awesome, Nomsa, with a little less than a minute to spare. All right, that's all the time we've got. Siama, I don't know how far you are, but let's have a look at these answers really quickly. All right, so in this case, when we calculate for the mean, we already know that they've surveyed exactly 100 households. So I know that the total here would be 100 values. All right, so my n is already 100 values. To find the sum of all of these, I'm going to go 0 times 5, 1 times 70, 2 times 21, 3 times 3, and 4 times 1. So I know 0 times 5 will just give me 0, 1 times 70 is 70, 2 times 21 is 42, 3 times 3 is 9, and 4 times 1 is 4. If I add all of these numbers together, I should get 125. So my mean is going to be 125 divided by 100, and that's going to give us 1.25. All right, but then again, this is talking about how many cars there are in each household. Again, this is discrete data. We can't get 0.25 of a car. So in this case, we would have to say between 1 and 2 cars per household. All right. Okay, for the mode, we're just going to look for the thing with the highest frequency. We're going to look for the number of cars with the highest frequency. That's 70, which means the number of cars is 1. The mode is 1 car per household. All right, for the median, again, we're going to use the position calculator, 1 plus n plus 1 divided by 2. Our n in this case is 100, so we'll have 100 plus 1 divided by 2, so that would give us 50,5. So we're going to look for the value in the 50th and the 51st position. That's what we're going to look for. Now, we can already tell the first 5 values are going to be zeros. So we'll have 0, 0, 0, 0, 0. And then the next 70 values are going to be ones. So we can already tell that by the time we finish with the ones, we would have covered 75 of those values, which means that the 50th and the 51st position would have to be 1. So our median is at 1 car. And our range is just going to be the highest number of cars minus the lowest number of cars. So for our range, we're just going to get 4 minus 0, which is equal to 4 cars. Okay, how did we do? Did we do okay? Those 4 questions, all good? Excellent. Good stuff. All right. Okay, so this is basically data handling in a nutshell. That's as far as it gets. What I want us to focus on now is measurement, and I don't understand what's going on with my whole thing because it's making life very difficult for me today. All right. Everything's just shifted, guys. I don't know what's gone on in my life here. But all right. So for things like perimeter or measurement in general, we need to know certain things in this case. Okay, it's very important that we understand the perimeter of certain shapes, the area of certain shapes. Sometimes they are nice enough to give you a formula if you're writing a test or an exam. Sometimes they don't. So you need to know for yourself what some of these formulas actually are and what they do. So the most important ones, or at least for me, are always the area ones, because you can use the area ones to tie the rest of them together. Okay, and I'll explain. For the perimeter of any shape, perimeter only exists for 2D shapes. So if we're calculating for the perimeter of a shape, even if the shape looks like this, it doesn't really matter. It doesn't matter, because as long as I've got that side, the length of each of the sides, right? If I want to calculate the perimeter of this, all I have to do is say perimeter is going to be equal to the length of A plus B plus C plus D plus E plus F plus G. So perimeter is easy enough in that whatever it is that we're calculating the perimeter for, we just need to walk around the outside and add all the lengths of everything on the outside. Thumbs up. Everybody, are you okay with that? Yes? Lovely. Okay, so perimeter is quite easy in that we can just calculate the outside of anything. The most important ones are going to be your area calculation. So we need to know that the area of a square is all two sides or one of the sides squared. The area of a rectangle is length times breadth. The area of a triangle is half base times height. We also need to know that the area of a circle is pi times radius squared. Ooh, excuse me. I don't know where I'm getting these hiccups from. Okay, so we need to know all of these. And the reason I say that is because if they ever ask you for anything above and beyond the area, for the surface area is just basically all the sides of a 3D shape put together. So let's say we have a rectangular prism, right? If we have a rectangular prism like that, right? And guys, again, I'm a maths teacher, not an artist, so please no judgment of my drawings. No judging ma'am's drawing skills. Okay, so if I draw a rectangular prism, right, and I need to calculate the surface area of my rectangular prism, all I'm going to do is I'm going to calculate the area of this. And I need to know that that is the area of a rectangle. So I need to know the formula for a rectangle. But this one and that one at the back look exactly the same. So I can just times the measurement of the front one by 2. Then I need to look at this one. I know that that is also a rectangle. If I know the area of the rectangle, I'm going to know what to do with that. The top part, same. The top part all together, that's also a rectangle. So if I know the formula for a rectangle, I'm going to be able to know the formula or the area of the top and the area of the bottom. We add all of those up to get the surface area. Okay. Always, always, always the same, right? Cylinder, same situation. A cylinder is a circle at the top, a circle at the bottom, and then a rectangular middle part. So if I know the area of a circle, I can calculate that. I know the area of this part. And now if I take this middle part and I unravel it, almost like a wrapper, right? If I show you here, I'm actually quite sick. So it's not helping. It's not helping. But this is a cough medicine bottle. If you look at this label that wraps around, the label is actually in the shape of a rectangle. So this middle part over here, the middle part that we're looking at over here, if we unravel it like we were unraveling a label, it would end up giving us a rectangle like that. So if we want to calculate the surface area, we would then need to know the formula again for a rectangle for the outside part. Am I making sense? Thumbs up. Are we all good here? Lovely. Okay, so if we know the area, it makes it so much easier for us. Same thing that we're going to get when we get to volume. Now, the volume of any shape, and I really mean it, the volume of any shape out there that is a prism is going to be the area of the base shape multiplied by the perpendicular height of the thing. Okay, let's go look at the formula that we have for volume over here. Okay. So you'll see here that the volume, they've given us B, that's the area of the base. So if I draw a rectangular prism, again, like that, if I draw that, it actually looks like a square-based prism, but it's fine, right? I know that the volume of my shape is going to be the area of this part, just the area of the bottom part, multiplied by the height. And then again, I need the area. So if I know the area of any of my shapes, my measurement becomes easier to do because I will already know the area of the bottom part. Then for the height, I just need to find the perpendicular height. And I need to emphasize that. Do you see how in these questions, like if you look at the cone and you look at the pyramid, they don't take the height like slant ways. It's never the slant height that they would take. It's always the height from the top of my shape all the way down to the middle of my shape. So if this is the base of my shape, they always go from the middle of my shape to the topmost part of my shape. And that is why in MathsLit, you need to know the theorem of Pythagoras. Okay, just thumbs up for me. Are you guys familiar with Pythagoras' theorem? Siamo says yes. Nomsa, what about you? I bet you we have seen it. It's just, it doesn't ring a bell at the moment. Okay, so when we talk about Pythagoras, if we have a triangle, and specifically the triangle needs to be a right-angled triangle, which means this angle over here needs to be 90 degrees. Okay, much like, look at this. If you look on the inside of this cone over here, can you see how they've created a triangle just like the one that I've drawn outside here? Yeah, I hope we're seeing that. Okay, so if we take the short side, okay, let's say the side is 3 meters long and the side is 4 meters long. We want to find the length of this long side over here. So what we can do, according to Pythagoras' theorem, is we can take the short side squared plus the short side squared, and that must equal the long side also squared. Okay, so if we want the long side squared, we're going to take this short side, so we're going to take 4 squared plus this side squared, which is 3 squared, and the answer we should get there, 4 squared is 16 plus 3 squared. That's 16 plus 9. So the long side squared is 16 plus 9. Therefore, the long side squared is equal to 25. But now I don't want the square of this. I want just the long side. So to take away the square, I'm going to go onto my calculator and I'm going to square root, because the opposite of my square is my square root. So I'm going to go and take the square root of 25. Can you punch that into the calculator for me and tell me what is the square root of 25? 5. Lovely. That's it. Nomsa, are we okay with this idea? Yes? It'd be 5 meters. So that means this side is 5 meters. All good. All good. All right. And the reason I don't like using the a squared plus b squared, it doesn't make sense, because what happens if this side is b squared? Now you don't know which side you're calculating for. But whenever you look at this kind of triangle, it must have a right, it must have a little square to show that it's a 90-degree triangle to start with, right? So we're going to have long side squared, it must equal the short side squared plus the other short side squared. And the reason why we want to remember short side is, let's say, for instance, they give us the long side and a short side. Now we need to calculate for the missing short side over here. So if we want to calculate for the missing short side, we're just going to change the formula just a little bit. We're going to say now, if I want the short side on its own, the other short side must go to the other side. So I can say short side squared is equal to long squared minus short squared. All right. So if I'm calculating for a long side, we're going to add the 2 short sides squared together. But if I'm calculating for a short side, I'm going to take long side squared minus short side squared. Thumbs up. Are we all okay with that idea? Yes, lovely, good. And I can show you guys how this works. If we're looking for the side here, we're going to go short side squared is equal to, now my long side is the 5. So I'm going to go 5 squared minus my other short side, which is 4 squared. So short side squared is going to equal to 5 squared is 25 minus 4 squared, which is 16. So short side squared would equal 25 minus 16 is 9. But I don't want squared, I want just short. So I'm going to take the square root of 9. What is the square root of 9? 3. the answer that we would get is 3, which is exactly what we had when we were calculating for the long side. So this side then becomes 3 meters. All right. Okay, and that's Pythagoras. That's why we use Pythagoras. Because in these questions where you have a cone, we always want this short side. This is going to be our long side, the one where we go long side squared. That's going to be our other short side squared, and this side would be the short side squared. So when we want the perpendicular height, the straight height, we will always be using Pythagoras in questions like these. All right. Okay. Something else that we also need to take heed of in measurements is your conversions. Okay. Now, grade 11s, I cannot emphasize this enough. You are not given conversions. So you need to put in all the different, you need to figure out all the different ways for you to remember how many centimeters are in a meter, how many millimeters are in a centimeter. It's important for you to know this stuff. Nobody's going to give it to you in a test. They're just going to give you something in milliliters, and then they're going to be like, give us the answer in liters. And it's up to you to know that there are 1,000 milliliters in a liter. And then you need to know whether we must divide or whether we must subtract. All of this, or whether we must multiply. All of this stuff is completely up to you to remember. Okay, thumbs up. Am I being heard loud and clear? Okay, nobody is going to give you any of this stuff. You're going to have to figure it out yourself. Okay, now the nice thing about it is, let me just see. Can you guys give me an indication? Do we know when to multiply, when to divide? Do we know when to do either of these things? Whether we're converting from liters to milliliters, when we're converting from kilograms to grams, or from centimeters to meters, do we know when to multiply? Do we know when to divide? Yes? Okay, Nomso says yes. Tiamo, how about you? Okay, cool. So if we're going from something smaller to something bigger, we must divide. But if we're going from a bigger number or a bigger measurement to a smaller measurement, then we must multiply. And that's something very important. The other thing that we need to remember is that they will give you measurements from metric to empirical and the other way around. I don't know why they wrote is it imperial? Am I the one who's saying it wrong? From metric to imperial or from imperial to metric. But they will always give these to you. The metric to imperial ones they will give you. So don't worry about that. It's the metric version or the conversions that we can do. I just need to double check with you guys. Do you guys know how to use your calculator to convert time? Give me a thumbs up if you know how to use your calculator to convert time. Nomso says yes. Tiamo, is that a no? Is that no? Okay, that's a no. All right, that's okay. We can go over this together. All right, so let's say, for instance, a question says to you, we have 4.5 hours, right? Now, 4.5 hours does not mean 4 hours and 5 minutes, does it? That's not what 4.5 hours means, right? That's not what it means. The 4 part, yes, is 4 hours. But the 5 is like 0.5. It's like 0.5, which is a half, which means we're looking for a half of an hour, which technically means that this must be 4 hours and 30 minutes and not 4.5. But this one we can see. What happens if I say to you, what is 4.3 hours? Now, we know that the 3 is not actually 3 minutes. So how do we figure out how to convert 3 into minutes on your calculator? So if you pick up your calculator, I've got this one. Okay, I've got this Casio. It's a black one. Even if you've got the white one or the blue one or the pink one, they will all do the same thing. Right. So the button we are actually looking for is the button here. It has, and my calculator is not being very clear, but it's got like a round, like it's got a circle, and then it's got 3 commas. Okay, give me a thumbs up. Do you see it? Right above it in orange, there should be a fact button. Good. All right, so that's what we're going to use. Here's what you're going to do. You're going to go on your calculator and you're going to click 4, comma 3 equals. Do that for me. Click on your calculator 4.3 and then click equals. And then I want you to click that button. Then click the button with the circle and the comma, comma, comma. What does your calculator do now? Your calculator should do this. It should go 4 circle 18.0 dot dot. Yes? Is that what your calculator's done? Okay. So what your calculator has now done is told us that 4, comma 3 hours equals 4 hours, 18 minutes, and 0 seconds. All right. Okay. How nice is that? Very easy for us to understand. Hey? Okay. Here's your next challenge. I want you guys to tell me, use your calculator to find me what 3,6 hours would be in hours and minutes. That's it. Lovely. Good stuff. Sorry, guys. I just needed to blow my nose really quickly. Good. Right. So if we put that into our calculator gives us 3 hours, 3 hours, and 36 minutes and 0 seconds. Okay. All right. So if they ever ask you how to do this, you can just do it easily on your calculator by clicking that button. Now, let's work our way backwards, right? Let's say, for instance, they give you an answer in minutes or in hours and minutes, and now you have to convert it to a decimal. In case, let's say, for instance, they want you to calculate for kilometers per hour. Now, when you're calculating for kilometers per hour, you need the hour, comma something. So let's say, for instance, they tell us that we've got 2 hours and 20 minutes. Now we need to convert this to 2, comma something hours. How are we going to do that on our calculator? We're going to do the opposite of what we did. So first thing we're going to do is we're going to click 2, and then you're going to click that button. Okay, so what should happen is your calculator will do this. It'll go 2, and then it'll open a little square like this. Okay, and then you're going to click 20, and then click that button again. 20, click the button again, and then it would open up another block like that. And then you need to click 0, and then click that button again. Okay, and then click equals, right? Now, what your calculator will do is it will go 2, that, 20, that, 0, that. I need you guys to then click SD. Click the SD button. Okay, and your calculator is going to give you a fraction. It's going to give you 7/3. Click SD again and give me an answer. What is your That's it. Well done, Tiamo. Your calculator will then give you 2,33333 recurring. So you'd get 2,3 recurring. That's just the same as 2.3 hours. All right. Are we all okay here? Yes. Can I give you guys one to try yourselves? Okay. I want you guys to tell me what 1 hour, 16 minutes. Let me do this. 1 hour, 16 minutes, and 10 seconds is in something, comma, something hours. So I want 1, comma, something hours, please, from your calculator. All right, tell me what the answer is. That's it. Good. Siamo, lovely. Good. We'd get 1.27 hours. Good. So it would give us 1 comma. It actually says 1,269,444, but we can cap it at 1,27 hours. All right. Okay, lovely. So shall we get on with an exercise? Let's do the exercise and see what we can do here. All right. So this is actually the example. So this goes here. So it says here, Mkhono sews dresses for children. The material costs 120 and 50 rand per meter, and she needs 3 meters of material to make a dress for a 6-year-old, 4.5 meters to make a dress for a 7-year-old, and 5 meters to make a dress for a 10-year-old. The embroidery cotton costs 15 rand 25 for a roll of 4 meters. She uses 3 rolls of cotton per dress. Use the above information to answer the questions that follow. Okay, so we're just going to be looking here and adding everything that we're seeing. So it says here, how many meters of material will she need to make the above 3 dresses? Okay, this would be an easy calculation. Okay, and then it says, what will the material cost for the 3 dresses? That's also an easy calculation, right? Because we're looking at cost. Then it says, calculate in centimeters. So now we need to take the answer that they've given us in meters there, and we need to convert it to centimeters. Now, nobody's going to tell you how many meters or how many centimeters there are in a meter. That's what you need to know. And you also need to know whether, when I'm converting from meters to centimeters, do I divide? Do I multiply? You need to be able to know that information. All right. And then it says the length of the embroidery cotton that Nkhono is going to use when sewing 1 dress. Okay, and then it says calculate the total amount that she will pay for the embroidery cotton. What is the total cost of a dress for a 10-year-old? Thumbs up. Can I leave you guys to do these 5 questions by yourselves? Yes? Okay, all good. All right, I'm going to give you guys about 5 minutes. I know we are out of, we're a little bit over time, but once we're done with these questions, we'll give it a bit of a rest. All right. All right, peeps, are we ready? Can we have a look at the answers? All right. Okay, let's start at the beginning. Okay, so point one says, how many meters of material will she need to make the above three dresses? Oh my goodness. Whew, English is leaving me. All right, how many meters of material will she need to make the above three dresses? Now, we just need to look at how many meters we need for each dress. So in this case, she needs 3 meters of material for the first dress for the 6-year-old, 4.5 meters to make the 7-year-old's dress, and 5 meters to make the 10-year-old's dress. So we just need to go 3 meters plus 4.5 plus 5 meters. All of that equals 12.5 meters. Right, that's number one. Okay, number two now says, what will the material cost for the 3 dresses? So the material would cost 12.5 meters times the cost of the material per meter. So 12.5 times 120 and 50 cents, and that gives us 1,506 and 25 cents. Okay. All right. For number 3, it says, calculate in centimeters the length of the embroidery cotton that Nkgono is going to use when sewing one dress. Okay. So in centimeters, it doesn't really matter which dress because they're just talking about when she's sewing just one dress. Okay, we've got 12.5 meters. Okay, we've got 12.5 meters. So we know that each dress, okay, for the cotton, they would need 4 meters. You can only buy this in rolls of 4 meters. Okay, so if we look at how much in centimeters each dress would need, that one would need 300 meters, or sorry, 300 centimeters. The next one would need 450 centimeters, and the other one would need 500 centimeters. Okay. When sewing one dress, 300, yes. Okay, this was this question is a little bit weird, and I don't know exactly what they're asking for. Calculate the length of the embroidery cotton. Okay, if it has a roll of 4 meters, she uses 3 rolls of cotton per dress. Oh, okay, so that's the part that I missed. Right, my apologies. So we need to look at, it says here she uses 3 rolls of cotton per dress. If one roll of cotton is 4 meters long, then we need to take 4 meters times 3, which gives us 12 meters of roll. But we need to take the 12 meters and we need to convert it to centimeters. Now, there are 100 centimeters in a meter, so 12 meters times 100 will give us 1,200 centimeters per dress. Okay, for each dress that they do, that she'll be sewing. All right, question 4 says, calculate the total amount that she will pay for the embroidery cotton. Now, we know that for each dress, she uses 3 rolls. Now, if there are 3 dresses, that would mean 3 times 3 rolls, which means she'd need 9 rolls to calculate or to finish all the dresses. Now, the problem is that the embroidery cotton is sold in a roll of 4 meters. Right? Or no, yes, of 4 meters, right? So each 4 meters, oh no, we just need to take the 9 rolls and multiply it by 1525. No, the 4 meters doesn't really matter. Okay, so we'll take 9 multiplied by 15 Rand and 25 cents. My apologies. 9 times 1525 is equal to 137 and 25 cents. Okay, and then question number 5, what is the total cost of a dress for a 10-year-old? So this one is a little bit different in that we're going to have to calculate for 3 things separately here. Okay, for question 5, we know that the total cost for the dress, right, for the material of the dress for the 10-year-old would be 5 meters. So we'd need to go 5 meters times the cost of the material for 5 meters. So 5 meters times 120 and 50 plus, we know that each dress uses 3 rolls. So we need to take 3 rolls times by the cost of those 3 rolls, 15.25. And we can punch this into a calculator the exact way that we're looking at it. Plus 3 times 15.25. And that gives us 648 Rand and 25 cents.